Hey guys, Ivan speaking here. On this video, we're going to talk about first normal form, data anomalies, redundancies, and we're going to have some scripts and some exercises if you want to follow along. The goal is to have this table to be in first normal form by the end of this video. And those will be the topics that we'll be talking about. First normal form, entities, attributes, data anomalies, data redundancy, primary keys. We're going to have then some demos, or in between some demos, and some exercises if you want to do it. I'll provide you a link where you can actually download the scripts, the SQL scripts, if you want to follow along. And you're going to need SQL Server, and you're also going to be able to complete exercises for better understanding. So first, normal form. So the main characteristics, or the three characteristics that force a table to be in first normal form must have are: one, attributes in its atomic form; two, no repeating groups; and three, rows must be unique. In other words, the primary key must be identified. So if you look into this table, what catches the attention if you think about it? Give you 5 seconds to think what is catching your attention, and here you go. The phone numbers, right? So Joe has 2 different phone numbers and Jennifer has 3 different phone numbers. They're all in the same column and they're all in the same field in the exact same record. Okay. So this is what we call atomicity issue, because these values, they could be breaking in two. For Joe, he has 2 phone numbers. So it should be 2 different fields for that, or columns for that, or whatever it is. I just couldn't have that in the same exact column or field. And Jennifer should have 3, right? So we have to split that out in a way that we won't violate the first normal form, because right now it's really bad, right? So before we do that, I want to talk about entities and records, so you have a better, clear understanding on what I'm talking about. So what is that? What are database entities? So understand this. In data modeling, there are a few blocks, okay? Few building blocks. An entity is perhaps the most, is the first one, right? And what is an entity? Entity is a thing or an event. What type of a thing? Anything, like a person, place, or what type of event? An event, like a game or party. So if you come to from the object-oriented world, that makes more sense, because that's how things are done there, right? We think of objects as entities somehow. So it's the same thing. The database, we can actually map those entities to objects in the object-oriented world, because they function in the same way, right? Um, Entities, they will have attributes, they will have relationships, and they will have constraints. And we'll talk about some of them now, but by the end of all the 3 normal form, uh, of the 3 normal forms that we will talk about, we're gonna have to have a good understanding of all of those. So, what is an entity? What is a record? Right? People sometimes think that entity and records is the same thing, but they're not. Okay, because not always an entity will be a record. I'm sorry, not always a record will be an entity. An entity will always be a record, and we'll see that in a bit. But this is a record because we have different entities in the same record. We are ignoring the relationship, the relationship that they should have in between them to create different entities are not here. We're putting all in the same record, which makes this not really an entity. This makes just a record. Okay, so for example, the person and the address should be 2 different entities. Right now, we have them in the same place. The phone number perhaps would also be in a different entity, depending on the type of constraint that we have in the database. But it's hard to see that in here now. But for address, it's very clear that we can see that an address, maybe it belongs to an entity, but it should not be the same entity as the person, right? Because person and address are 2 different entities, right? So this is not an entity, this is a record. So here are some of the definitions. The entities are represented by tables in a relational database, and attributes are represented by columns in the entity table. Records are entries in that table. So here's a definition. An entity will always be a record, but a record will not always be an entity. Okay, and we talked a little about we talked a little bit about those attributes, and he was saying that they are virtually immutable, meaning the first name of a person will not really change, right? I would say at least that much. Maybe someone doesn't like their first name and they want to change it. That's fine, but it's not something that if they change it once, it's going to be probably once in their life. The last name, when someone get married, they may change it, but it's not something that they change every year, right? For 50 years, maybe they'll change every once in a while for marriage purpose, right? A race, no one. How are you going to change a race, right? So they're kind of like they're not changeable. Those attributes from an entity. Okay. So let's talk about data anomalies now. And I'm pointing that out that phone number violates atomicity. And again, it's just because I have two records in the two values in the exact same record, right? In the same field there in the phone number, right? And that causes problem in the main operations of the database, which are insert, update, and delete. And even for queries, if you want to select, I mean, it could be challenging sometimes to find what you want. You still can get it, but insert, update, and delete, which are the main things in the database, so that we can save records. Those are things that are really hard to do it, and let's see why. Okay, so this is the script that we're going to be using for the demo. You're going to be able to download the script if you want to. I'm going to put the link right below so you have the way to actually follow with me on this and make sure you understand the concepts of first normalization. And I will. So I have here. I'm gonna use this database course. So if you don't have it, it's gonna be created for you right there, right away. Okay. And let's go and use that. And I'm gonna now create the table that will be the same as we are having in the presentation. And if I go select here, this is what we have. Okay, exactly what we saw in there. Okay, we have those records. Joe has 2 phone numbers. Jennifer has 3 phone numbers. And now I want to see if I can actually insert a phone number to Michael. Okay, so let's say that I want to add another phone number. Okay, in that case, I would need to add another phone number right here, right? So I'm going to try that and let's see what happens. Well, I actually got a record with 2 phone numbers, but now I also created, but it was an addition of a record of Michael Moon, which I think is the same. This could cause confusion later on. So I can't really do an insert the way I want. Okay? Or you might say, okay, well, I could maybe just insert another record like this. Let's see what happens here. Yeah, same way. I mean, I would have 2 Michael Moons. It's not here. Okay, this is actually be better because now I don't have 2 phone numbers. But the insert that I want to be showing up here, it didn't, and it won't, right? So how do I do if I want to actually? And let me clean this up. If I actually want to do an insert right here for Michael Moon, I would have to do what? I would have to do this. And I'm putting the question there, is this really insert? Well, let's see what happened. Look, now he has 2 phone numbers the way I wanted. Awesome, great. But look at that. That's an update, that's not an insert. So I am not able to do a clean insert if I have atomic issues. A clean insert would be an insert right here. Okay? So I'm not able to. I had to do an update. So now we know that we cannot do it, right? So I already have that in there. So the other problem is, let's say that now I want to attach some more phone numbers for Michael. Oh, problem with the constraint on my data type. I have a bar chart 50, which is actually very generous for a phone number. It would be much less, 10, 12, I don't know. But I mean, I put it here so you could see it. Like, I don't know how many phone numbers a person will have, right? It could have 10, 100, who cares? Or if my database care, I cannot put those phone numbers there. Why? Because I have a limitation. And I should not come and change this. Change this is a sign that we have a very bad database design. Okay, so this should not be changed. And but I'm also missing. If I do that, I'm missing. I'm trying to do an insert, which is truly an update, and I'm missing data, right? So again, the other problem is a constraint with the data type, right? We can have that. Now we can try to do an update, okay? So let's see what we have here. Let's go for an update and see if we can have an anomaly. So I have here my commune with this phone number. 2341255 is that even here? 1256. Okay, so look, if I try to do an update here for Michael Moon now that he's got two phone numbers, okay? Actually, I want to do different. I want to show you something else because this can sometimes fool ourselves. Let me just come to the regular one. Let's try to do an update for Michael Moon. Okay, now we only have one Michael Moon. And then we do an update. And if we look at it, we're going to see that it changed. And we're like, oh, okay, I can actually do a clean update, right? Well, you could do a clean update for someone who has one single value in there. But what about Joe? What about Joe, right? So I want to change the phone number for Joe. Okay, I want to change 1, 2, 3, 4, 5, 6, 7, 8, 9, 6. But what do I want to change? Do I want to just eliminate everything? Or do I want to just change one of those phone numbers? Right? If I run this here right now, what are we gonna have? It changed, right? But it was like, is that what I really wanted? Maybe I want to change a different phone number, not only one of those, not two. So let me insert them all again. All right, they're there. And let's see now. If I do this, okay, I could say, okay, now I actually want to change just a part of the phone number, and you want to be like, and phone number equals to, for example, this, right? The 90 is one that we have in there, right? So I want to change where the phone number is like 7890 to 7896. And if I do that, it's like, oh, it didn't change any record. Why? Because the whole string is a phone number, not only portion of it. So you require some logic to accomplish this update. So I cannot do a clean update. We saw that I can only do a clean update if it has one atomic value, and that made us think that this was good, but when it's not really good because it wouldn't apply for Joe, I mean. You applied for Michael, but you didn't apply for Joe. Okay? So that's a problem, right? So now I want to do an update. I'm sorry, a delete. Let's see if I can do a clean delete. And who has the 1256? None of them have here. I think it's because I was adding 1256 to Michael, right here. So let me actually do, let me do something different here. Let me just correct this a little bit. Let me do this. Let me see what is the value for Michael. And let me actually change that here. Put that in the delete. Okay, so I want to delete this phone number for Michael. Well, I didn't only delete the phone number, I delete the whole record. So Michael is gone. I don't have Michael anymore, right? So if I actually want to do a delete for Michael, I would have to do something else. This is what I would have to do. Let me clear this up. I have to do an update and set the phone number to empty. So let's try that. So now I got rid of it, but look at this. This is an update. It's not a delete. And also, if Michael had more than one phone number, if I'm trying to delete, for example, the phone number for Joe here, this phone number, how would you do that? The second phone number. How would you do that? Or you'd have to delete the whole record, or you'd have to do an update with a bunch of logic in it. Really hard to do it, right? So those are the three anomalies for insert, update, and delete when we have atomicity problems, okay? Also remember that we had the problem with the data type, the varchar constraint of 50. If we need to do an update and someone has like tons and tons of phone numbers, then what? So during that demo, you saw that we cannot do a clean insert. We have limitations with the constraint because in that case, the varchar 50 was a limitation. We also cannot do a clean update, and we cannot do a clean delete. So those are very clear anomalies. Another anomaly that we can have is called another problem that we can have in a table that's not in forced normal form is the repeating groups, because we may think that, okay, now I'm going to fix the atomicity by creating another column, and that, that then I'll be good, right? But here's the thing, and some people call that they're kind of the same thing. I don't know if they're the same thing or not. Who cares? As long as we understand the principles, right? So that's what we call the repeating groups. They come in two flavors. One is atomicity issue, as we saw previously. The other one is when we have same type of data saved in different columns in the same table. So he is the one well, before we had this, now we have this one, right? Where I actually add another column, phone number 2. Let's forget Jennifer for now because she has 3 phone numbers. But like Joe, now his phone numbers are in atomic form because phone number 1 only holds one phone number value, and phone number 2 holds only one phone number value. However, I have the repeating groups, right? Because those two columns hold the exact same type of value, and it shouldn't. Okay, and we're gonna see what are the problems that's caused with that. Okay, so let's go to the demo. Okay, now let's see the repeating group problem, right? So let me start by deleting and create a new database, a new table structure. At this time, I have 2 phone numbers, phone number 1 and phone number 2. Let's do some inserts and select and see what we have in there. So now, and let's ignore Jennifer for a bit, okay? Let's just think of Joe and the other ones. So Joe now has an atomic values in its phone number, right? The difference now is that I have 2 different columns, each one with different phone numbers, and we're good. The other ones, they keep having their phone number, but they have a bunch of nulls in here. And we will also talk a little bit about nulls in a bit. But let's say that I want to add a new value, a new phone number to Michael Moon. Okay, so this guy here, we want to add a new one with a clean insert. Can I really do that? As you can see here, I did a clean insert, but I actually had to add another row. So this created data redundancy and also confusion because this Michael does not have a phone number 1, but it has a phone number 2. And I mean, that's not what I want, right? So let me do this again. Let me try the other way. Let me actually try to add those 2 phone numbers and see what's going to happen. So I added Michael again. It's a different record, even though it has almost the same exact information except for the phone number 2. But now I have this 2, and I really don't know who is who. So I still was not able to do it. Okay, so let me do this. So what am I gonna have to do to put that phone number here for Michael, right? And I have a similar issue that we had before. Instead of doing an insert, I end up having to do an update. So if I do that now, then it's there. But what about this? Was that an insert? Nope, it wasn't, right? Now let's say that I want to do an update for Michael. Okay, I want to do an update. I want to update the phone number where is 1256, right? And well, actually, here's the phone number that I already have. So let's do and put this to 8. So we saw that an insert doesn't work, right? What about an update? Well, if I do that and I set phone number to 2, we'll see that the update actually worked, okay? Because now I have the phone number I did, and it was a pretty clean update. And that was clean. I mean, considering that I have the primary key, okay, this would work, right? But if I have redundancies like I had before when I inserted, for example, this guy here, if I do this, And if I do that, you would have changed in two different places. And I'm not sure if that's really what I want to do, right? And anyway, this is, I didn't even want this record in the first place. So, I mean, even though I can do a very clean update, it can be confusing, okay? If we have all these redundancies. Now, what if I want to do a delete? So I want to delete where phone number is 1256. And who has that? Oh, right now I don't have anyone with that. So let me do this update here again. So that's Michael, and in these two records, that's he's got that phone number. So if I do this, what happened is that I deleted not only the phone numbers, but I also deleted Michael. So Michael doesn't even exist, and maybe that's information that I did not want to lose. So that delete didn't work. But if I try this, if I try an update instead and set that to no, well, first of all, let me do, so Michael, he's null. Let me give him a phone number again. So now his second phone number is okay, right? And if I do an update, which I'm actually looking for a delete, update, and now I have a select, and here we go. All right, so not able to do a clean delete either. Now, what if Michael has another phone number that I want to add? That's the third one, and we got an issue. Why? Because I only have columns for two phone numbers, not three phone numbers. So should I be adding phone numbers 1, 2, 3, 4, 5, 6 here? No, right? That's a problem. And so I don't want that, okay? So we saw that we cannot do a clean insert again. We have issues with the number of columns, right? Because if someone has a bunch of phone numbers, are we going to put how many columns there for phone numbers, right? We cannot do a clean update. I mean, we actually can. So I guess, we saw that we can, but it's quote, open quote, can, because it's not clear the type of update we're doing there, right? We could mess up things pretty easily. But in the defense of the update, we are actually able to do a clean update, right? But we also saw that we could not do a clean delete. Clean delete is really was just didn't work. Okay. Now, what about the nulls? Let's talk a little bit about nulls, because as developers, sometimes we use the null values in a really bad way. Okay. Nulls should mean unknown. For example, let's say that I need to enroll my cousin in a school. He calls me. Let's say that I work for the school, and he calls me and say, "Hey, can you enroll me there?" And I, when I go there, I give whatever, provide whatever documentation needed. Said sure. Then I enroll him in a course, and in that course, they ask for his date of birth, and for whatever reason, I couldn't get his date of birth. I tried to call him, I couldn't. He wouldn't answer, so I couldn't get his date of birth. Well, I know for sure that date of birth is something that he has. Everyone has it, right? It's an attribute that he has it, and that's not going to change, right? So at the time I do the enrollment, I'm going to put a no value there, like meaning it's I don't know. But eventually he's going to come back and he's going to, we're going to ask him and we're going to be able to update that and put the right value. So that's what no should be used for unknown values, not for things that people don't may not have. For example, phone number two. So a phone number two, the majority of people has a phone number one, and a good amount of people has phone number two, but not every people has a phone number two, right? So if they don't have a phone number two, if there's a possibility that a person doesn't have a phone number two, then there's no reason to have a column for number two. That's because in that case I'm going to have to put a bunch of nulls, and if I put a bunch of nulls, that's actually a good indication that I might have repeating groups, and my table is not in the first normal form either. So As we can see there, we could maybe even create another column, right? Phone number 3. Look at that. Now Jennifer, she has all the spots, but again, what if she has 100 phone numbers? Would I have phone number 100 times there? Not good, right? So now I see that this is bad. This is also bad. And this is also bad. They're all bad for first normal form. Okay. So what should I do? Here it is. This is in first normal form. Okay. So I think we can just celebrate, right? Well, um, let's celebrate it, but let's check this demo and see why this is in first normal form. And also, I want to emphasize here that some people say, okay, you're missing the primary key. After the demo, we'll talk about the primary key and see why we're not missing a primary key here. Now, I'm not saying this is a good design. I'm just saying that we're not missing a primary key here. Okay? So let's go back to the demo. Okay, now to finish this up, let's make this in 1NF, first normal form. Okay, so here I have the table. I created a structure with only one single phone number. Then I'm going to do a bunch of inserts. And what we see here now is that this isn't first normal form. Okay? Remember this though. We still have a lot of data redundancy here, and this can cause a bunch of issues. That's why we have other different normal forms, but this isn't in first normal form. Okay? The redundancies here are, for example, Joe Black. I'm considering this guy the same. All right? And his phone number is different here, but he's the same guy. Jennifer also, I have 3 of her. If I have to add another Michael, or here I have an example. If I want to add another Joe Black with the same address, same zip code, I'll just do this, do an insert. And I did, with a clean insert, I was able to add another Joe Black. Okay, this guy here, right? I created more redundancy, but it's right now we're not really too much worried about redundancy. We'll be start worrying about that in the next lessons on the next normalizations. All right, so the same for Crystal. So if I add Crystal with a clean insert, she's there. I didn't have to do any update. It was just a clean insert. Just another record that was added there, right? So what if I want to do an update? If I want to do an update, I will have to find a primary key for it. Okay, in this case, this is my primary key. Not a good one, but I'm not worried about that right now. But if I want to update for Joe Black, whatever his phone number is, 0000, do I have that? This one, right? So with one single update, I can do that. And now his phone number is 0001. Okay. What if I want to delete that phone number, right? Well, if I just do a clean delete, what happened is it's not there anymore. I did a clean delete. I still have Joe Black. Okay. I still have data redundancy, but this is his first normal form. Okay, and we'll talk more about. All right, so primary key. So there are a bunch of different keys in the database, right? Here I'm naming a few of them, right? And eventually we'll talk about all of them. But for now, I'm only really concerned about the surrogate key, composer key, and primary key. Okay. So primary key, let's first understand what is that, right? Primary key is pretty much the chosen key. As long as it makes that record unique, it's great. It can be used as primary key. Okay. Now, surrogate key is a primary key with no business meaning. Meaning, like when we see, for example, numbers, especially we usually, as developers and the business world, we use that as numbers, at auto numbers, right? So 1, 2, 3. So like an ID of 1, 2, 3, 100, 101, 1001, whatever it is. That's a surrogate key. What does that mean? That means that it's just for the system. It's just for me to be able to query, to do things. It doesn't have any purpose in the database or in the business. I mean, sorry, it has purpose in the database. It doesn't have any purpose in the business, right? The bank is not going to care if the person is ID 1 or ID 1 billion, right? So it just has no meaning to the business. And what is a composite key? Composite key is just a primary key with more than one column, right? So sometimes we think that we can only use one column as a primary key, but no, we can use as many as we want. Of course, the more we use it, the more complicated it will be, especially for our joins. But we can use as many as we want, and sometimes those are valid. There are valid reasons to do that. So in this table, we actually have, if you look at it, I said that's in the first normal form because right now this is each record is unique. So I could actually use every single column as a primary key. That will be a composite key with all those columns, right? If I use all of them, that's a composite key, you know? Again, is that a good design? No, that's horrible. That's bad. But it is. It is in primary. I mean, I can use that as a primary key. And in that case, this table would be in first normal form because I don't have atomicity problems. I do not have repeating groups, and I have unique record in the table. I have unique records in the table, right? If I am to add another Joe Black with the same phone number, same address, and same thing, then you would not be in the first normal form anymore because I would have repeating group, not repeating groups. I would have repeating records, and that violates the first normal form. But the way it is here right now, we're good. So for summary, what we saw in this lesson was the characteristics of the primary key, entities, attributes, then anomalies, redundancy, the primary key. We also had some demos, and you can actually complete the exercises as you want. Again, the how to do it is right here down below. In the next lesson, we're going to talk a little bit more about database keys, functional dependencies, and cardinality. Okay, we also going to have some demo exercises, and understand that before we move on to the second normal form, it's important that we know those concepts. Okay, and after that, then we're gonna break down that table a little bit more so we can go to second normal form. But for now, follow to the next lesson, understand better what are database keys, what are functional dependencies, cardinality, and it'll be good. And again, if you like it, make sure you subscribe it. Also, here's the link for the next video. Thank you. Have a great study time.